Hey everyone, welcome back. Today we are diving into a classic problem that almost everyone runs into early in their coding journey. We are tackling Leetcode number 9, Palindrome Number. Let's break it down step by step and make it easy to understand. Here is the problem page. It looks pretty straightforward, but there is a neat follow-up constraint that makes it much more interesting. Let's look at what we need to do. A palindrome is simply a value that reads exactly the same whether you read it from left to right or from right to left, like the number 121. For example, 121 is a palindrome, but negative 121 is not because reading it backward gives us 121 followed by a minus sign. Similarly, 10 reads as 01 when reversed, so that is also a no. By the way, if you ever get stuck or have questions during this video, please drop a comment below. I make sure to respond to everyone and help out. As always, we will write our main explanation using Python, but do not worry if you use another language. I have complete solutions in Java, C++, and JavaScript ready for you at the end of this video. Our first approach is the most direct one. We convert the integer into a string, reverse that string, and check if they are identical. Here is the Python code for this method. We simply convert the input variable x into a string and compare it directly to its reversed version. If you want to grab this code without typing it out, you can head over to leetcodeunlocked.com/palindrome-number. The link is right down in the description. For this string method, both the time complexity and space complexity are big O of log base 10 of x, because the number of digits in our number determines how much memory and time we need to create the string. But wait, the problem asks us if we can solve this without converting the integer to a string at all. This means we need to use pure mathematics. Let's see how we can do that. To do this without strings, we can reverse the back half of the integer and compare it with the front half. This is a neat trick that also keeps us safe from integer overflow issues. Before we do any math, we can handle some quick edge cases. First, any negative number cannot be a palindrome. Second, if a number ends in 0, it must start with 0 to be a palindrome, which only happens for the number 0 itself. Let's visualize this with the number 1221. We can extract the last digit using the modulo 10 operator to get 1. This becomes the start of our reversed half. Then we divide our original number by 10 to get 122. In the next step, we take the last digit of 122, which is 2. We add this to our reversed half, making it 12. The remaining part also becomes 12. Since our remaining part is no longer larger than our reversed part, we stop. Here is the complete math-based implementation. We handle our edge cases at the top, loop to reverse the second half of the number, and then compare the two halves. Notice how the final line handles both even and odd digit lengths. If the length is odd, like 12321, our reverted number will end up as 123, while the remaining x is 12. We can safely discard the middle digit by dividing the reverted number by 10. By avoiding string conversion, our space complexity drops to a constant big O of 1. The time complexity remains proportional to the number of digits, which is log base 10 of x. Now, let us take a look at the implementation of this math-based approach in other popular programming languages. First, here is the complete Java solution. It looks almost identical to our Python code, utilizing integer division to discard digits. Next, we have the C++ version, which follows the same logical flow and structure. Finally, here is the JavaScript implementation. Note that we must use math.floor when dividing to perform proper integer division. To wrap up, this problem teaches us some great lessons. Handling easy edge cases upfront saves work. Reversing only half of a number is a smart way to prevent integer overflow. And basic operators like modulo and division are incredibly powerful for number manipulation. I have changed the format of our videos a bit to make them faster and cleaner. I would love to hear your thoughts on this new style, so please leave a comment letting me know what you think and ask any questions you have about the code. If you want to support this channel, you can buy me a boba at buymeboba.com/leetcodedaily. Do not forget to like and subscribe to catch the daily Leetcode problem early. Happy coding and see you next time.